Is a really nice graph theory problem from the University of Melbourne School Mathematics competition. All students at your school with an even number of school friends send an email to those friends. All students at your school with an odd number of school friends send an email to those students at your school who are not their friends. Show that you will always receive an even number of emails from fellow students at your school. So in this example, there are 3 students with 2 friends each and 2 students with 1 friend each. The even students send 2 emails to their friends. The odd students each send 3 emails to those students who are not their friends. But this question is about the number of emails that you receive. So say, for example, you are one of the even students. You get 2 emails from your even friends and 2 emails from the odd students who are not your friend. If you're one of the odd students, you don't have any even friends, and you don't have any odd non-friends, so you get no emails. It's still even. In both cases, the total number of emails you receive is even. Let's look at another example, this one with 6 students and some more complex friend relationship. Say, for example, you're this student with 4 friends. Only one of your friends has an even number of friends. So you get 1 email from that even friend, and you get another 1 email from an odd non-friend. That's 2 emails, which is even. If you're this student with 3 friends, you'd have 2 even friends and 1 odd friend. So you get 2 emails from your even friends and 2 emails from your odd non-friends. Again, it's even. The total number of emails received is always even. But why? So there was actually a hint provided with this question in the competition, which is to first show that there is an even number of students with an odd number of friends. And we can prove this by starting from the fact that the sum of all student friendships must be even, because each friendship is counted twice in the total sum, so the total must be even. In graph theory, we could say that the sum of the vertex degrees is always twice the number of edges. So subtracting the sum of friendships for the even students from this sum must still give an even number. That means the total sum for the friendships of the odd students must be even, which then means that there must be an even number of odd students. Because if there was an odd number of odd students, the sum would be odd. Okay, so that proves the hint, but then how does that help us to solve the problem? I'll get to the clever, unexpected solution a little bit later, but if you're anything like me, you might try a case analysis. So if we classify students into even friends, odd friends, even non-friends, and odd non-friends, then of course there's also you. We can set up the students in a table like this, and let's break it down into cases. So case 1 being you have an even number of friends. Now we already had from the hint that the total number of odd students must be even. Now we need 2 more cases. Let's say case 1A is where your odd non-friends is even. In that case, all those 3 cells in the table must be even, and more importantly, the sum of your even friends and odd non-friends must be even. Case 1B then is where your odd non-friends is odd. We get these 3 cells being odd, but the sum of those 2 odd numbers again must be even. Case 2 then is where you have an odd number of friends. Now we know from the hint that the total number of odd students must be even, but here that actually also includes you because you have an odd number of friends. So the total number of your odd friends must now be odd. Again, we can break it down into case 2A. If your odd non-friends is even, we get a sum of 2 even numbers. If your odd non-friends is odd, we get a sum of 2 odd numbers, which is still even. So there's a proof by cases, but here's a clever solution which I didn't think of, and I bet you didn't either. Imagine what happened if you left the school. So in this diagram, we've got all the even students on the left, all the odd students on the right, and your friends are in the red circle. When you leave the school, your friends all lose a friend, so your even friends become odd and your odd friends become even. But now from the hint, we know that the sum of these students, which is all the odd students at the school, must be even. But that sum is exactly the sum of your even friends and your odd non-friends when you were at the school. So their sum must still be even. Isn't that clever?